So today I'm going to talk about some of the tools we have developed in the CORECLIMAX project. It's basically to evaluate climate data record production, and also its suitability for specific applications. I should first of all thank my co-authors, York Schultz and Rob Roblin. They both humans had, and also to the entire CORECLIMAX team, because there were lots of interactions during the course of the project, and we got a lot of good comments that helped us to improve these tools. My talk is organized in this way. First, I will give a brief introduction. So why do we need to assess climate data records? And then go through the evaluation and the quality control process. It's first of all, the system maturity metrics, that is to evaluate the process of the development of climate data records, and then checking the scientific quality and the fitness for purpose. And then I will just briefly go through the relations of these tools in relation with the GCOS guidelines. Okay, so the motivation. So in this GCOS WCRP letter to many of the agencies which develop climate data reports, they say that there is currently no systematic international approach to ensure transparency, traceability, and sound scientific judgment in the generation of climate data records. And they continue. There are currently, as an example, there are currently 8 CIS concentration products produced by different organizations globally that differ significantly in providing an estimate of sea ice extent and concentrations, mostly due to differences in the methodology and not due to the variability or dynamics of underlying phenomena. So this is a good motivation to look at the process of the climate data record generation and see why data records for a particular variable is differing a lot. And due to this large variability among them, the data sets are not very suitable for monitoring climate. So that is the first motivation. And then there are a set of GCOS guidelines for generating ECV climate data records. I will not go through all of those. You can basically read. So this is to ensure that there is a full description is made, and also the accuracy, stability, and all those technical details are specified and documented and made available to the user. And it should be easy to access and access the data set and also the documents associated with the data sets, so that the user can make an informed judgment on whether to use the data set or not. And then calibration and validation is very important, and that has to be done properly and documented. And then the timeliness of the release of the data set. Yesterday, there was a talk that, for some applications, the users have to wait for months to get the data, and that limits their, limits the usability of data sets. So, to ensure that the timeliness is kept, and also, to summarize the documenting all these guidelines, whether all these guidelines are followed. So basically, develop the tools to make sure that these set of guidelines are followed, to check whether these set of guidelines are followed by followed during the data set generation. And it's another motivation is, and it's a user perspective. So the user is, they got a new good data set, and or they need some new good data, and they found the data. A data product could be very good, but if it is not convenient to use, and if it is not described properly, then it is not good for me. A user will conclude like that. So the user will go go with whatever they already have and they already know about. So then, how do we ensure that all these best practices are followed in a dataset generation? Dataset generation of the essential climate variables. This is just to give you a flavor of the variables we are dealing in the climate change. There are three themes. One is atmosphere, then the ocean and terrestrial, and you might be working with some of these climate variables. So I will not go through all of them. You can look at them later. And so in this CORECLIMAX project, we work mainly in work package 2. In the work package 2, we want to assess the European essential climate variable dataset generation capacity. So UMassad is leading it, and IPC, Viju, and DWD, FMI, and MTF are partners in this activity. So what are the benefits of our activities? So we want to provide a consistent view on the strengths and weaknesses of the processes to generate, preserve, and improve CDRs to each individual CDR producer, agencies, and also to the European Commission, and provides information to user community on status of the individual records and also collective state of all records in Europe, and provide this information for the first time across different observing and production systems like the satellites, in situ, and reanalysis. So far in the past, there were such activities, for example, looking only for satellite data or looking only for in situ data or reanalysis. But now we want to have assess all production system in one framework. And then also, this activity can improve the transparency and openness towards the user, so the user will be able to assess, actually see what is going on in the data generation. And also, this kind of repeated assessments will help to monitor the progress towards, the completeness of the system. And also, it potentially supports selection of CDRs for climate change services, particularly the Copernicus climate change service. And then it can contribute to the next climate modeling the comparison project. So that's a part of that is ops forming. So all the data set assessment in this activity could be contributed to the CMIP6 project. So in the CORECLIMAX framework, so we developed a three-step, or three assessment tools. The first one is the data record description. So we made a generalized form for describing each data record. So I will come to that in the next slide. So that contains, this data record descriptions contain the technical specifications and the links to documentations and the quality and so on. And this provides then a consistent and coherent information about the climate data record produced in Europe. And the next tool is the system maturity metrics. The system maturity metrics is evaluating if the production of a CDR follows best practices in science, engineering, and also it's assessing whether the data set is used widely and whether there are feedback mechanisms with users established. And the system maturity metrics can be used in self-assessment, so the data set developer can actually see what are the strengths and weaknesses in the production of the data set. And also it can be used as like an audit type of assessment. So for example, in a climate change service, they want to see whether a data set is, production is sustained so that they can use that in their climate change system, climate change service system. And so the system maturity metric is looking only at the production part, not the scientific quality of the data set or a suitability for a particular application. And then we have the third tool, which is the application performance metric, which evaluates the performance of the CDR with respect to a specific application. So this might be implemented as an interactive application which convolves the user requirements with the product specification given in a database. So we will come to the details of all these things in the next slide. So the format of the dataset description is like this. So first it will give like a brief description of the CDR offender, so what quantity is there and so on. Then one of the important point is the point of contact. So the user wants to contact and get some more information about the data set. So that is coming next. And then the data field description, the technical specification like what format it is, what variables in there, units and so on. And then the next point is the origin of the data, like whether it is a satellite, or in situ and so on. So it describes the input data and a bit about the quality of the input data and so on. And then the next one is the most important part. It's about, how well the data record is validated and what are the uncertainty estimates in the data set. So the user will get the information on the state of uncertainty in the data set. So, it's not too detailed that one can write a brief description and then point to some of the documents describing the detailed validation and so on. And then it gives, some strengths and weaknesses for particular applications, like the limitations to be considered. For example, yesterday David was telling that when you use reanalysis data for trend analysis, be aware, and things like that is mentioned in the considerations point. And then the point 7 is not very important for most of the users. That's why it's put later on. So it's detailed description of the measurement system. For example, if a particular satellite instrument is used, then the technical details and the measurement principles and so on is coming in point 7, and then the references and so on. So this document is supposed to be only like 5 to 6 pages. So it gives mostly a flavor of what is, a flavor of the data set, but then putting more like links and references so that the user, the interested user can go and find. So basically it contains most of the information, the user would need. So we had a CORECLIMAX assessment workshop, dataset assessment workshop in Darmstadt. And then there were like 30 climate data records. They filled in this form, and they also, then we went through this, other tools like system maturity metrics and application performance metric. And then we developed a common understanding of the system maturity metrics. So it was a 3-day workshop. We discussed, what are the limitations of the tools developed and where we can improve upon and so on. And then we discussed these 30 data sets. The developers of these 30 data records, they filled in the system maturity metrics I'm going to describe in the next slides. And then we discussed the results of the assessment, and then we agreed upon the way forward and so on. So this is the concept of the system maturity metrics. So basically there are like a few questions asked. Is the software that developing the data record is robust and maintainable? That's very important when it comes to a climate service or climate change service, because they want to have the data set for next several decades. So they want to make sure that, okay, the production of the data set, the software which produces the data set is robust and it's also maintainable, so there won't be any additional cost involved later on in the service. And then the next question is, are the data and methods well documented? And that's very important for the user. And the other question is, has the trueness of the data been systematically assessed? The trueness of the data can be assessed by doing validation and estimating the uncertainties. And then are the data well used and the user feedbacks taken care of? I mean, as David was telling that, okay, they produce one reanalysis and then it gives to the user, then they use it, they feedback, I mean, what's problems and so on. And then they go for another reanalysis. So, and then it's basically, I mean, it's the feeding back the problems and then improving upon what's already there. So these are the basic questions we are assessing in the system maturity metrics. And so we have 6 categories to look at. One is the software readiness, and then the metadata and user documentation that covers basically the documentation part. And then the uncertainty characterization is checking the trueness of the data, and then public access, feedback and update, and the usage columns are addressing the last question. So we started this work from an existing framework that's given in Bates and Privet in this EOS article in 2012. So there, I mean, the maturity matrix looks like this. So they have software readiness, metadata, documentation, product validation, public access, and societal impacts. And the maturity goes from 1 to 6. So when a data set has a score 1 or 2, it is categorized as a research grade data record, and when it is 3 and 4, it's a initial operational capability that it can be taken into a climate service or an agency service, and then it can be operated in an initial way. And then when it gets into 5 and 6, that is a fully mature climate data record in terms of the production. And that is fully operational. And they don't need additional resources and so on to maintain the production of the climate data record. We don't need to read that. We will come into all those things later. So what we improved or what we did to the already existing maturity metrics. So we made it applicable. The NOAA one, the Bates and Privet one was meant only for the satellite data and for use stage in the NOAA climate data record program. So then we took it and made it applicable for in-situ data record and also for reanalysis. So we took out a lot of satellite-specific language like ATPD names like that. And then we also made it more easily applicable for agencies worldwide. So we took out a lot of NOAA-specific or agency-specific language. And then we had a lot of interactions with data developers in Europe and worldwide. So that's ESA, CCI, UMETSAT, satellite application facilities, and NOAA and the USGC and so on. So, and we got a lot of comments and feedbacks, and so we incorporated that and we made it more mature. And then we concentrated it on questions of completeness in sense of following best practices in science and engineering. That's developed over several decades. And we made the maturity metrics independent of individual applications, and we separated that part and put it into application performance metrics. And then we also used a cumulative approach for increasing maturity and improve consistency between the main and sub-matrices, and we will come to that, and among sub-matrices. So this is the CORECLIMAX system maturity metrics, and now we kept the software readiness, metadata, user documentation names as they are, and we changed the product validation into uncertainty characterization. So product validation is just one part of the uncertainty characterization, and then then we included the public access, and also we included the feedback mechanisms and how often it's updated and such characteristics of data set development. So here we can, in some detail, go through the different categories. Maybe we don't want to go into too much details. This you can read later. So, for example, in the software readiness, so we first defined coding standards. So, coding standards is like a set of rules or conventions specific for each coding language to follow, so that the possibility of introducing bugs is reduced, and also for later on for code review it's easy when a programmer has followed these standards. So we first check whether the software developed has followed some coding standards. So first, for the initial, for the research grade code, we don't expect that the developer has followed some standards. For example, a PhD student in the university is writing codes to develop some initial data record, and we don't expect that they're following any standards. So it's good if they are following, but we don't expect. So it's a research grade code. And then, when a data set is maturing in that aspect, it is standard is defined or identified, but it's not applied. Then a standard is partially applied, and then when it gets full maturity, it says that standard is defined, standard is applied, standard is fully checked in the code, and the code is fully compliant with the standard. So then it gets a full score or score 6 in that category. It's similar for other categories as well. So for software documentation, it starts with no documentation, then it goes up to like enhanced descriptions of in the processes in the code, and the user manual is complete, and the software installation manual is complete, and so basically you can read these things later on. And then again for metadata, the next category is metadata. In the metadata, also we have defined some standards. So for existing standards like the CF standard for NetCDF, so or there are standards for each program. For example, in NOVA there are some standards for metadata. In UMETSAT there are some standards for metadata to keep in the files. So it could be an international standard like CF standards, or it could be standards like organizational standards that could follow. But it's important that a data set developer is following some standards and sticking to the standards. So the maturity goes like how well they are sticking to the standards. And then the collection level metadata is like the overall details of a data set, like for example, which instrument is used, what version of the software is used, and so on. So that is applicable to the whole collection of the data. And then there's a file level metadata, like for example, if it's a gridded data set, it is for each grid point, like the quality of the data or the uncertainty of the data. Such things are contained in the files. So then if there is a complete, pixel level or grid level or station level metadata in the files, then it gets a score 6. So it's basically, this tool is assessing whether each of these things are followed in data set development, and so based on how good they followed best practices, they get different scores. And the next one is user documentation. The user documentation, we have 4 categories. The first one is the formal description of scientific methodology. In case of satellite data, it could be an algorithm theoretical based document. It's called ATPD. And for in situ, it could be a manual for measurement principles, or manual for post processing, or how do for example, how they do the interpolation how they grid it, how they homogenize the data, and so on. So how well that is documented? So that's the first question. And then cumulatively go, like there's a draft is available, a journal paper, the methodology is published, and then it cumulatively goes to score 6, and there's a comprehensive scientific description is available, and then the journal paper of the product is published whenever the product is updated and so on. So it's basically checking the documentation is done properly. And then a validation report. So how good is the validation report? Is it available? Is it properly written? Is it available to the users and so on? Then as a user guide is available. And then again, a formal description of the operation concept is there. This is important for when a data set is taken from, for example, in a university group or and to the climate change service. So they want to have all the system imported to the new place, and so this formal description of the operation concept is important in that case. So it's basically it's checking. All these things are properly done, and then give scores based on the state of the documentation in that category. And the next category is uncertainty characterization. So there basically, some standards are identified or developed for validation and characterizing the uncertainty. And the highest score one can get is, and the standards are followed, and then there's a site traceability to the measurements of the data set is established. And then how well the validation is done, whether it's limited, for some locations, or it's a global validation. And or the data set is participated in some international assessments like the GWEX data assessment, for example. And then how well the uncertainty is quantified and provided, and that is the next column. And is there an automated quality monitoring while generating the data set? Is checking for outliers and so on, and then feeding that back to, for example, to the metadata. And next category is the public access and archive. So the first column is checking whether it is available easily, and then the next is checking whether the version control is established, so the user can really follow what has changed in different versions of the data sets. And is there a feedback mechanism established, like is the data set developers meeting the users like in a regular manner, like there are like user workshop every 2 years or 3 years to collect the feedbacks from users, and then it's feeding back to the data set generation procedure. And the last one in this category is how often it is updated. So the highest score is the capacity. There's a capability for fast improvements in a continuous data provisions established. That is like interim climate data records. So that means it may not be a full-fledged climate data record, but for the last month data is available this month, or last week's data is available this week, something like that. So there is a mechanism for providing continuous data in a timely manner. And then the last category is checking the usage of the data, how well it is used in research and also in a decision support system. The use in research can be estimated by checking the publications written out of one data set, and also the use in the decision support system, for example, whether the data set is used in IPCC or whether the data set used in a national report checking, describing the impacts of, for example, sea level rise and so on. So these are the 6 categories we are checking. I hope you got a flavor of what we are looking and how the data set can be assessed for checking, assessed for following best practices. Okay, so this is not an easy procedure. I mean, getting maturity is not an easy thing. I mean, it takes time. So over time, the data set will get mature. This is one example. I mean, this the top one is the ESA CCI sea surface temperature record. And it's running for that program is running for about 5 years. And you can see that. I mean, it's not very mature in the categories. But if you look, for example, the climate monitoring, so you must have climate monitoring of cloud data record, and that program is now running for 12 years. You can see it has most of the columns are on like 4 or 5. So the point I want to say is if a data set is not getting high scores, it doesn't mean that it's a bad data set. It takes time. I mean, you have to see the length of the generation and so on, and then just because it got low scores, it doesn't mean it's bad. I mean, you have to see the plans and so on to see whether the program will sustain and they are going to improve upon these things. And one thing we clearly noticed, for example, in our workshop in Darmstadt is the difference between satellite data and in situ data. For in situ people, in situ data set developers, they get very low scores in the first column, that is the software part, and also in the user documentation. But they get very large scores in the usage and public access and so on. Because in situ data is, most of the times it's a reference data, and also the in situ data available for a long time, so that it's used a lot. So, and it's used in IPCC reports, it's used in impact assessments and so on. So they get a very high scores for usage. But they are somehow very weak in providing the documentation and also providing writing good software. So at the beginning, the software, in situ data developers were not so happy with this assessment. But then they realized that making good software is important, writing good documentation is important. So we think that it's a good exercise to interact with them and somehow convince them that other categories are also important, not just the metadata or the usage. So this tool is very important for, more useful for a dataset developer than a dataset user. And then era entering also is one of the mostly used datasets. So they get a very high score in usage, and the software readiness, for example. It's not just a small piece of code. It's a bit complex. The code for the numerical weather prediction model, and also for the data assimilation system and so on. So it's a big piece. It's a monster code, and it's difficult to follow standards and so on in that. That's why it is getting a low score in the software readiness. And it's not a bad thing. It's how it is. So we have to understand each system to interpret the scores. It doesn't mean that, reanalysis gets score 1 in software readiness, so it's a bad thing. So we cannot say that. This tool has to be interpreted in an informed and educated way. Okay, so that is basically a description of the system maturity metrics, and I provided you some examples. So for example, for the practical session, if you are a dataset developer, or if you want to see how good is a dataset during the production, you can actually go through this maturity metrics. And also we have written an instruction manual, and that's all in this computer module. I will send it to you, or you can download it from the CORECLIMAX webpage. And so it basically describes how to give assign scores and so on for each categories. So that could be a good example for the practical session later on. And for example, you can check the reanalysis error engine and see how different you are getting, how your scores are different from what David and Paul did, and then to see like an independent assessment of the system maturity metrics for error engineering with a user perspective. So the system maturity metrics is actually not checking the fitness for purpose of the scientific quality of the data. So system maturity metrics is only assessing whether the data set can be sustainable in terms of engineering, science, archive, and usage aspects. There's no guarantee that a data set with a high system maturity metrics is suitable for all applications. For example, there's a data set X with overall system maturity metrics 5 or 6 that provides daily mean humidity values. It's not suitable for assessing diurnal cycle of humidity in climate models. So it is the temporal resolution is not enough. So the user, the user wants to know all the technical details before he decides whether a data set is usable for a particular application or not. So how do we assess the performance of a data set for a particular application? So the questions asked in this category are these. This is some examples. So just the coverage of the record is sufficient for that application. Is there sufficient level of detail? Like all the technical details, like the temporal sampling, vertical sampling, horizontal resolution, and so on. And are the observations of adequate quality? So are the uncertainty characteristics provided matching with the requirements of the application? And how does the quality of the data vary in time? Is there a time varying uncertainty in it? And is that suitable for a particular application? So we have like coverage, sampling, uncertainty, and stability are the main things. We are actually looking in this application performance measure. This is basically the general concept of the application performance metric. So a user has a particular application and specific requirements for that application, and then the user should be able to search through a large set of the product specification tables of the climate data records available for that application, and then match the requirement and match the requirements with the technical specification of the data sets, and find out one or more data sets suitable for that application. So that is the basic idea. And to do that, the basic framework we need is a good database of all these technical specification of the climate data records. And currently we don't have such a database. So currently what we have is the ECV inventory, you might know. So the ECV inventory provides some or most of the technical details a user needs for this essential climate variable data records. And you can, if you Google for ECV inventory, you can see, the details of that and what sort of information in the inventory. So we plan, may not be part of the CORECLIMAX project, but as a follow-up of this one, we plan to boost the ECV inventory and make a good database, and then develop a user interface to search the database, and then match the requirements with the database to select one or more data sets suitable for a particular application. So this is the general concept. And the product specification table, what can go into the database would look something like this. So it will have some indicators like information in the first part, and then the main things are coming in the second part, like the technical specifications, like what variable is there, what is a systematic uncertainty, what is a random uncertainty, what is the temporal stability, also like resolution, coverage, and all those things could go into this database so that a user can easily search and then make informed decisions on which data set to be used. To explain this concept, I thought that I will go through one example. So that we, during the workshop in Darmstadt, we went through this exercise in the ocean breakout work group where I and David was participating. So we formulated a hypothetical question that the policymakers asking a question: are there trends in North Sea temperature over the last 15 years that could affect fisheries? So it's a hypothetical question, and so we wanted to then develop an application performance metric exercise based on this question. So which are the data records suitable to analyze trends in this rather small region? So first of all, one has to come up with a user requirement table for this particular application. So the first column is we have to select the essential climate variable for this, and that is the temperature or ocean surface temperature. And then the user requirements are divided into 3 categories. So there's a target category, that's a minimum data set. I mean the minimum requirement the data set should meet. And then there's a breakthrough category, that is the column here. And then there's an optimal requirement. Optimal means data record is satisfying that, to that level. That means it is no further improvements is needed in that particular aspect for that data set. So the first one to look at is the coverage. So the data set should cover North Sea, because we want to analyze the temperature trend in the North Sea. If the data set is a very good data set, but it's available only in the tropics, there's no use for this one. So first of all, we have to see whether that data set is covering the North Sea. And then a temporal resolution. The temporal resolution is that the target is monthly, it should be at least monthly, weekly is better, and if the data set is coming in daily, daily files is the best. And then we look for horizontal resolution. It should be at least 100 kilometers, 10 kilometers, okay, 1 kilometer is the best. And the vertical resolution, it is a sea surface temperature, so it could be any, surface or some depth in the on the sea surface. The breakthrough could be 100 meter, and we are very happy if it is coming in the first 100 meters of the sea surface. And the length of the record, because we want to see whether it's changing over the last 15 years. So the minimum we want is from 2000 to 2014. And for trend, it's not really possible to estimate trends from shorter time series. So we want to have it more for the robustness of the trend. So 30 years could be a breakthrough, and if we have 45 years, that would be more than sufficient for estimating trend for the last 15 years. And then we go for accuracy or the stability. So we decided that the stability is more important when we analyze a trend. If uncertainty is varying over time, or if the data is not homogenized, the trend estimated from the data may not be the true trend. So we want to focus on the stability there. Though the target stability could be 0.67 Kelvin per decade. The breakthrough is 0.33, and the optimal is 0.2. And so we first developed the user report. So that's essential for using this application performance measure. Then we thought that okay, we will take 2 sea surface temperature data sets, and then look the technical specifications of that. The first one is the hard ISSD1. That is a sea surface temperature data set developed at the Harley Center of Met Office And the second one is the CCI, ESA CCI sea surface temperature analysis. So these are basically the the technical details the user is asking for. The ECV, the physical quantity, sea surface temperature, the top few meters, and for this, the CCI data set it is at the 20 centimeter because it's only a satellite base. So they know the, it's infrared base, so they know that it's coming from, the emission is coming from the 20 centimeter level, or the peak information is coming from 20 centimeter. And both data set, the coverage is global, so it's covering North Sea, so happy. And then the temporal resolution for the first data set is monthly, and the CCI is daily. And the horizontal resolution is, so we want to look for the horizontal resolution at the region of interest. It's 80 kilometers at 60 knot, and for CCI data set is 5 kilometers 60 knot. And the vertical resolution is it's coming only from one layer. So, and the length of the record is 1870 to last month. So it's a regularly updated data set. The CCI one is it started in 1991 and it finishes in 2010. The stability wise, hard ISSD is 0.1, but the CC analysis is much better. It's a 0.03 Kelvin per decade. So it's much better in terms of stability. But there are some caveats. For the hard ISSD, it's not a time readings. Accuracy, it's only one global value for the last 150 years. And also for the CCI analysis, they determined uncertainty of stability and based on the tropical Pacific. So we are not sure whether this is really representable for the North Sea region. So then we applied, we then matched the user requirements with the product specification table, and then we assign the scores based on, a data set gets score 1 if it is matching threshold, and score 2 if it's matching breakthrough, or it's also for target, and it gets score 3 when it's matching the optimal or the core. So these are the scores we got for these two data sets. So coverage, because both data sets are global, so for coverage it gets optimum score, score that is a 3. And the temporal resolution, hard ISSD is matching only the minimum, so it gets only 1, and the CCI is getting 3. And for horizontal resolution, it's getting 1 and 2. For vertical resolution, it's only meeting the minimum requirement, so it's only 1. And the length of the record, that's interesting because this data set, the CCI, is very stable and it's better in most other things, but it's not covering the required time period. For that particular application. So it starts only in 1991 and ends in 2010. So it's getting a score 0. So yeah, and then for stability, both data sets get score 3, but you have to keep in mind that these stability values are not assessed for the particular region of interest, so that's why we put it in orange color. So this is one example of using this application performance metrics. So the user will get basically some color-coded information like this, and then the user can actually go through this course and decide, okay, so even if, for example, the CC analysis is getting green for more categories, but it's getting only red for the length of the request. So one can decide, okay, this is not suitable, I don't want to use this data set. But then they have to, maybe they think that, okay, so if I use this data set although it's not covering the entire time period I'm looking for, but it's better in terms of stability and so on. So why don't I assess the trend for this time period, 1991 between 2010, and then maybe I get an idea whether it's changing or not, so that I can interpret whether it's changing also during the last few years. So the user can basically go to, look at these scores and then make an informed decision whether I want to use a particular data set or not. So that's the basic idea. And so the plan is that we will actually, we want to make a big database, putting together all the technical details of the data sets of these essential climate variables, and then develop an app to match the requirements with the technical specifications, and then come up with a table or a matrix like this, so that the user can see and then make an informed decision. Okay, so I'm coming towards the end of my talk. So after this workshop, we presented this at many different meetings and workshops and so on, and we got a very good response from them. For example, this will be used in the stage 0 of the Copernicus climate change service to select, for example, data sets for the service. And then also we presented it to the COCGMS working group for climate, and it was received very well. And also in the WMO framework, they want to encourage UMETSAT to work with WMO to establish a WMO guideline out of these CORECLIMAX results. And also, this is now used in another international project called COPCM, that is for sustained generation of climate data records. So, this is getting a bit popular in different areas of the climate data set generation. Okay, so now there are GCOS guidelines for creating dataset reports, and so you can basically go through this. I will not explain everything. So which of these 3 tools is covered by the guideline principles? So you can basically go through this. Yeah, I think I finished my time, and thanks for listening. And if you have any questions, I'm happy to discuss.